Aluminum. Aluminum is a silvery white lightweight metal. It also has density lower than those of other common metals at approximately one-third that of steel. It doesn't rust. Only metals containing iron, including steel, can rust. It's the world's most abundant metal, consisting of about 8.2% of the Earth's crust. Aluminum also is recyclable. This product can be smelted down and reused in other applications. Why use aluminum? Aluminum is used in external facades, roofs and walls, in windows and doors, in staircase railings, shelves, and other several applications. Aluminum is also good for its durability, low maintenance costs, finishes, reflective properties, not combustible, and eco-friendly. Forms and uses of aluminum in architecture. Extrusion. Extrusion is a process of which metal or other material is forced through a series of dies to create desired shape. There are three main categories of extruded shape: solid with no enclosed voids or opening, hollow with one or more voids, and semi-hollow with a partially enclosed void. Forms and uses of aluminum in architecture. Alclad. A corrosion-resistant aluminum sheet formed from high-purity aluminum surface layers. Metallurgically bonded high-strength aluminum alloy core material. It has a melting point of about 500 degrees Celsius or 932 degrees Fahrenheit. Aluminum sheet and strip. A roll-forming operation is a continuous bending of a long strip of coiled aluminum sheet into a desired cross-section of profile. Structural aluminum. The most popular aluminum structural are 6061 and 6063. Aluminum angles, beams, channels, and tees can be used in various applications due to their unbeatable strength to weight ratio compared to other metals. Aluminum door. Door made of aluminum is lighter and especially less prone to corrosion than other metal doors. Certain alloy can make it stronger. Aluminum windows. Better security is also a top concern when buying new windows. Aluminum is a stronger and more durable material than vinyl and offers structural advantages due to its build strength. Also, the quality and design of blocks can help increase the levels of security of your windows. Aluminum panels. Used in residential and commercial construction, often as external cladding and building facades. Mechanical finishing is great for achieving different textures, and its benefits lie in the aesthetic feel of the material that it provides. Chemical finishes. Modify the surface of aluminum through one or more solutions. The main reason for using a chemical finish besides its cost effectiveness are to clean the surface to move soils for a future finish. Electrolytic finishes. A process that replicates natural occurring oxidation by providing a protective metallic film on the aluminum surface. Electroplating is widely used in industry and decorative arts to improve the surface qualities of objects. Porcelain or vitreous enamel. Process of fusing a thin layer of glass to a metal object to prevent corrosion and enhance its beauty. Paint. Architectural coating or paints are paints that other coating used paint the exterior and interior of buildings. Let's go to iron. Iron dissolves readily in diluted acid. It is a gray metal. It is tough. It rusts in damp air. It dissolves readily in diluted acids. Cast iron is a group of iron-carbon ions with a carbon content more than 2%, an alloy of iron that contains 2 to 4% carbon along with varying amounts of silicon and manages and traces of impurities such as sulfur and phosphorus. It is made by reducing iron ore in a blast furnace.
So now let's talk about steel. Steel is a combination of iron and carbon. Steel is alloyed with various elements to improve physical properties and to produce special properties such as resistance to corrosion or heat. Alloy steel refers to a type of steel that is alloyed with various elements. Carbon steel can be wrought, rolled, cast, and welded but not extruded. Structural steel is a rolled steel that is used in construction or building projects. Reinforcement of concrete, usually deformed bars of varying grades and diameters. Steel sheet. Steel sheet is made from low carbon steels, generally containing about 0.15% carbon and not exceeding 0.25% carbon. Strip. Strip by definition is a sheet material that is 12 inches or less wide. It is used in fabricated form as decking galvanized sheet. Corrugated steel. This is rigidized sheet fabricated from low carbon cold or hot rolled steel sheets which are either galvanized or covered with some type of bituminous coating. Stainless steels, generally used in architecture, are highly alloyed steel that contain more than 10% chromium. They are characterized by their resistance to heat, oxidation, and corrosion. Copper. Copper is ductile, malleable, non-magnetic metal with characteristic bright reddish-brown color. Has the highest electrical and thermal conductivity of any substances except silver. It is highly resistant to corrosion by air and salt water. Tin. Tin is a soft, ductile, malleable, bluish-white metal. Because it is normally covered with a thin film of stannic oxide, it resists corrosion by air, moisture, sulfur dioxide, hydrogen sulfide. Zinc. Zinc is medium-hard bluish-white metal. Is characterized by brittleness and low strength. Is readily attacked by acids, alkalis. It is resistant to corrosion by water. On exposure to air, a film of zinc carbonated or oxide forms which protects zinc from further oxidation.
So first up is brass. Brass is an alloy or mixture of copper and zinc with small quantities of other elements added onto it to improve it. When in terms of advantages, brass is superior in workability and resistance to corrosion, but its downside is that it's less hard and strong than steels. We commonly see or use brasses in terms of lightweight things such as doorknobs, screws, nuts, railings, and more. Another is chromium. Chromium is a steel white metal which takes a brilliant polish and is harder than cobalt or nickel. Chromium is used in terms of making stainless steel, hardened steel, to manufacture stainless steel as well, and other alloys. Another one is nickel. Nickel is an inert silvery metal. It is resistant to strong alkalis and to most acids. In our daily lives, we usually use nickel in a form of a 1 peso coin. If you recognize it doesn't corrode easily, it is because it has the ability to withstand high heat. Nickel also minimizes corrosion, allowing the metal to be used for several decades without replacement. The last one is lead. Lead is a blue-gray, soft, very heavy metal and considered as the heaviest of the common metal. It is extremely workable, has good corrosion resistance, is easily recovered from scrap materials, and is relatively impenetrable to radiation.
So number 1 is soldering. It is a method to join metals to make electrical connections to seal joints hermetically with another lower melting metal or alloy called the solder. We have also soldering, letter A, metal bath dip, defined as the metal joining process where the workpieces to be joined are immersed in a pot, molten solders. We have also soldering iron and torch. Soldering iron is this method. The iron piece is preheated and applied to the joint along with the solder and the flux. The flux is a substance used in soldering to clean surface such as metals. So we have also torch. The parts to be soldered are preheated by torch flame and then the solder flux are applied. We have also brazing. Brazing is a type of soldering in which the operating temperatures are higher but lower than in welding, which stronger or higher melting alloys are used to fill joints. Also welding. Welding is the process by which two metals are so joined that there is an actual union of the interatomic bonds. Also, lastly, the rivets are devices used to join or fasten the metals. The rivet, a metal cylinder or rod which has a head at one end. So it is a device that used in applying metals to join it and also to fasten it inside of the metals.
Concrete reinforcement is also known as rebar. It provides extra strength from the buildings, houses, and other constructions such as roads and bridges. It tends to have a long service life with relatively low maintenance and in turn low maintenance costs. What are the metals used for concrete reinforcement? First, we have steel bar. Reinforcement for concrete constructions is mostly in the form of steel bars and rods of round or square cross. So basically, sa mga construction site nga atong nakakita, mainly din nilang ginagamit nila for concrete reinforcement kay steel bars. Another methods for concrete reinforcement is what we call war fabric. War fabric is made up of cold-drawn steel that is widely used for the reinforcement of concrete slabs, and as well as for stucco works. So it is generally used sa atong mga salog, ground floor to rooftop. Third methods for concrete reinforcement is expanded mesh. It is manufactured from solid steel sheets. To form the expanded mesh, the sheet is first cut or pierced in a staggered slats or pattern. Then the sheet is pulled by the two sides parallel to the slats and stretched by the pressures. So basically, it is a diamond-shaped war fabric. The pattern style here kay mura siya diamond shape nga window in this formation. It is commonly used for metallic lat to support plaster or stucco. Aside sa concrete, pwede sa di siya magamit sa fences or even gate. And the last methods for concrete reinforcement kay ang lats. Any material fastened to the structural member of a building to provide a base for plaster. When we say plaster, it is used for coating walls, ceilings, and other partitions. These lats are furnished either in flats or segmental sheets, pressed into a series of solid ribs between which the metals are stamped, perforated, or deformed into an open meshwork.
The first metal is a metal containing iron as a principal element, while non-ferrous metal is any metal containing little or no iron. Now let's talk about ferrous metal. Now iron is a ferrous metal. Now pig iron is crude iron that is drawn from blast furnace and cast into pigs in preparation. Now undercast iron is malleable cast iron. Cast iron that has been annealed by transforming the carbon content into graphite and removing it completely. Now undercarbon steel is mild carbon steel, a low carbon steel containing from 0.15 to 0.25 carbon, also called soft steel. Now we also have medium steel, a carbon steel containing from 0.25 to 0.45 carbon. Now hard steel, a hard carbon steel containing from 0.45% to 0.85% carbon. Now spring steel, a high carbon steel containing from 0.85 to 1.80% carbon. Now let's talk about alloy steel. Carbon steel to which various elements as chromium, cobalt, copper, manganese, molybdenum, nickel, tungsten, or vanadium have been added in sufficient amount to obtain a particular system or chemical properties. Now under alloy steel is stainless steel. We also have high strength, low alloy steel, weathering steel. Now we have zinc, chromium, tin. Now let's talk about non-ferrous metal. Now first is aluminum, a ductile, malleable, silver-white metallic element that is used in forming many hard, light alloys, often anodized for better corrosion resistance, color, and surface hardness. The symbol is AI. Under aluminum is heat-treatable alloy, an aluminum alloy capable of gaining strength by heat treatment. Non-heat treatable alloy, an aluminum alloy capable of gaining strength by cold working, also called common alloy. Alclad, duralumin, a light strong alloy of aluminum, copper, magnesium, and manganese. Next is copper. Next is lead. Next is brass. Under brass is first red brass, an alloy from 77 to 86 copper with the balance zinc. Next is aluminum brass, an alloy of about 75% copper, 2% aluminum, small amounts of other elements with the balance of zinc. Next is common brass, an alloy of about 65% copper and 35% zinc. Next is naval brass, an alloy of about 60% copper and 40% zinc. Muntz metal, an alloy of from 35% to 61% copper with 39% to 45% zinc, also called as alpha beta brass. Next is bronze. Traditionally, any various alloys consisting essentially of copper and tin, and sometimes traces of other metals. Under bronze is silicon bronze, an alloy of 97% copper with 30% silicon. Next is gold bronze, an alloy of about 90% copper, 5% zinc, 3% lead, and 2% tin. Phosphorus bronze, a hard corrosion resistant alloy of about 80%, 10% tin, 9% antimony, and 1% phosphorus. That's a lot. Next is aluminum bronze. Any of various alloys containing a high percentage of copper from 5% to 11% aluminum and varying amounts of iron, nickel, and manganese, also called bronze. Commercial bronze, an alloy of about 90% copper and 10% zinc. Architectural bronze, an alloy of about 57% copper, 40% zinc, 2.75% lead, and 0.25% tin. Manganese bronze, an alloy of about 55% copper, 40% zinc, and up to 3.5% manganese. Okay, now we have antimony, a brittle crystalline silvery white metallic element used chiefly in alloys, the symbol being Sp. Cadmium, a white ductile metallic element resembling tin, used in plating and making certain alloys. Carbide, a very hard material of carbon and one or more heavy metals, as tungsten carbide used for cutting edges and dies. Next is magnesium, a light ductile silver-white metallic element used in lightweight alloys, symbol Mg. Next is manganese, a hard brittle metallic element used chiefly as an alloy element to increase the hardness and toughness of steel, symbol Mn. Nickel, a hard silvery white malleable ductile metallic element used in steel and cast iron alloys and in electroplating metals which requires corrosion resistance, symbol Ni. Nickel. Next is silicon, a non-metallic element having amorphous or crystalline forms used especially in electronic devices and to strengthen low alloy steels, the symbol Si. Tungsten, a heavy metal brittle gray white metallic element having a high melting point and used in electrical element and for hardening alloys, the symbol W. Vanadium, a malleable ductile grayish metallic element used in forming alloys, the symbol V.